In the last mini-module, you were introduced to case series and case control studies. Here, we will talk about two more common approaches. As you listen, consider whether their strengths and limitations will suit your project's purposes. First up, we have correlational studies, also known as ecological studies. Correlational, also known as ecological studies, use population-level data to examine the relationship between exposure rates and disease rates. The primary study question is, do populations with a higher rate of exposure have a higher rate of disease? So, for example, do people living in a more democratic country have better health? This approach is used when the aim is to explore possible associations between an exposure and a disease, by seeing if there are big trends in disease rates and exposure rates. What makes it different from case control studies is that it uses population-level data, which means aggregated data about large groups of people, which allows the researcher to cast a wide net. This wide net allows possible trends to jump out and help researchers identify potential hypotheses for further study. Importantly, this aim can only be used when the topic has not already been explored using individual-level data, meaning data gathered about individual people. This is because individual-level data can tell us about associations between disease and exposure within the same person, which is a lot more useful than merely finding trends in the population. So if we already have solid individual-level information about a disease exposure association, there's no need to identify this potential association using a correlational study. Also, in this approach, it is especially important to define your variables well, because you will likely be working with huge amounts of archival data, and it's easy to get lost among the numbers. The correlational study approach is only successful if you can identify a good data source that has the variables of interest. Refer to Module 3 for good places to start. The exposure and disease or outcome data used in correlational studies are in aggregate form. In other words, data are about a population and not about individuals. For example, the data may include the proportion of each population with a particular characteristic. So, for example, X amount of teenagers or X% of teenagers in Alaska have used recreational drugs in the past, and also the rate of a certain outcome. For example, X% of female Alaskan teenagers become pregnant before the age of 16. Because these are aggregated data, we don't know that for any individual teenager, using drugs is related to pregnancy. We can only say that in the pool of all teenagers in Alaska, these two variables happen to co-occur. The analysis of correlational data will only be valid if the data points are comparable. So if data comes from multiple sources, or if data are collected using different methods, then the data cannot be validly aggregated. So in other words, you can aggregate apples with apples, but not with oranges. In some populations, exposures and diseases may be under or overdiagnosed. For example, attention deficit hyperactivity disorder, or ADHD, is likely overdiagnosed among wealthy white children, but underdiagnosed among less wealthy racial, ethnic, and minority children, and we're not really sure why. In this case, we cannot put the data for all of these children together to analyze because we know there is some methodological difference between how the groups of children are diagnosed. This is an example of why researchers should interpret ecological associations very carefully. To better understand how correlational or ecological studies work, you will read an article by Franco and colleagues, published in 2004. The assessment in this module will probe your understanding of the study's methods and findings.